In this video, I will talk about the open loop configuration of an operational amplifier. So, what is the open loop configuration or open loop connection? Open loop connection, that means there will be no direct connection between the output terminal and any of the input terminals. If let's say I call this is our operational amplifier, it is its inverting and this is its non-inverting terminal, and this is its output terminal. I am biasing this op amp with plus Vs voltage source and minus Vs voltage source. If this output terminal don't have any connection with either inverting or non-inverting terminal, therefore that circuit will be known as open loop configuration of an operational amplifier. Now, when an operational amplifier is an open loop configuration, depending upon on how many number of inputs we are applied, the open loop configuration is classified into two types: single-ended input and double-ended input. Single-ended input, that means we will apply the input voltage at one of the input terminals, either inverting or non-inverting terminal. If I apply the voltage to the inverting terminal, therefore that will be known as inverting mode. See here in the circuit we have an operational amplifier, and I am biasing this operational amplifier with plus Vs and minus Vs source. This is its output terminal. See here, the non-inverting terminal is directly grounded, therefore Vp will be equal to 0, and I am applying the input voltage at the inverting terminal. Therefore our Vn, inverting terminal voltage, will be equal to input voltage Vi. If the voltage difference between non-inverting and inverting terminal is Vd, therefore our Vd will be equal to Vp minus Vn. Vo equal to AVD, A into Vp minus Vn. Here Vp will be equal to 0, therefore it will be equal to minus AVN and Vn equal to minus AVI. See here, output voltage Vo equal to minus AVI. Vo equal to minus AVI. That means the input voltage will get inverted at the output side. If I consider this sinusoidal voltage as our applied input voltage, therefore our output voltage will take this shape. See, during positive half cycle, input voltage will go through positive half cycle. If I multiply that positive value with this negative value, I will get an output that will be invert, that will be 180 degree out of phase with this input voltage. During this negative half cycle, our input voltage will be negative. If I multiply all the instantaneous values of the negative half cycle with this minus sign, therefore I will get an output voltage which will be the amplified output voltage of our input signal. Therefore, see, for inverting mode our Vi and Vo will be 180 degree out of phase. Now consider the non-inverting mode. For non-inverting mode, we will apply our input voltage at the non-inverting terminal, and inverting terminal will be directly grounded. Therefore you will see that if the voltage difference between this terminal to this terminal is Vd, here Vd will be equal to Vp minus Vn. Vp minus Vn, here the Vn will be equal to 0, therefore our Vt will be equal to Vp, and you will see that the Vp is the voltage difference between the non-inverting terminal to ground, and I am applying the input voltage at this terminal, therefore Vp will be equal to Vi, therefore our Vd will be exactly equal to our Vi. Therefore if I consider the output voltage Vo equal to AVD, it will be equal to AVI. Our output voltage will be AVI. That means if I consider this sinusoidally varying quantity as our applied input voltage, see, during the positive half cycle our input is going through positive value, therefore this positive Vi will be multiplied with another positive term, therefore our output voltage will give a value which will be positive. Okay, and during the negative half cycle, input is going through negative, Vi will be negative, therefore negative term with positive multiplication with a positive value will give us a negative value. That means here I will get the input voltage Vi and Vo in same phase. If I apply our input voltage at both the terminals, that will be known as a double-ended or differential mode. See, at the non-inverting terminal I am applying our input voltage Vi1, at the inverting terminal I am applying Vi2. Therefore Vi2 will be equal to Vn and Vp will be equal to Vi1. Now our Vd is the voltage difference between non-inverting and inverting terminal. Therefore our Vd will be equal to Vi1 minus Vi2. Therefore you will see that our output voltage will be Vo equal to A into Vi1 minus Vi2. Okay, now let me draw the input and output waveform when we are applying the input voltage at both of the input terminals. Our let's say Vi1, the voltage at the non-inverting terminal, let's say start with its positive half cycle. From this point to this point, input Vi1 will be positive. From this point to this point, our input voltage Vi1 will be negative. Now our applied voltage at the inverting terminal should start with negative half cycle. That means our applied input voltage will be 180 degree out of phase with respect to each other. Now our output voltage Vo is the difference of our Vi1 minus Vi2 and multiplied by our voltage gain. Therefore our output voltage, let's say this is our output voltage Vo. See, from this point to this point our Vi1 will be positive, and from this point to this point our Vi2 will be negative, and that negative value will get multiplied with the negative sign in front of it. That means I will get a positive value during our positive half cycle. Therefore our output will give us an amplified output voltage which will start with positive half cycle. Now our Vo was equal to A into Vi1 minus Vi2. You see that here from this point to this point our Vi1 is negative, and from this point to this point our Vi2 is positive. So when this positive value will get multiplied with this negative value, this will give us another negative value. So this negative and this negative value will give us a greater negative value. Therefore our input voltage will go through amplified negative half cycle, and here you will see that the voltage Vi1 and Vo are in phase. Therefore I can say that when I am applying the differential mode, the non-inverting terminal voltage and our output voltage will be in phase. Okay, that's it. Thank you.